cbsenews.com.
Okay, now we are at the YouTube. Here press the search button. Okay, then type which chem. Then which chem YouTube channel will be opened. So as lot of videos are there, lot of topical videos are there. So how to search them effectively and easily smartly. So press here which chem. Okay, then you will get home videos and playlist community channels and about. Then you press playlist button. Okay, so in the playlist you will get one shot series, chapter wise series, exam information and previous year question, 3D series, lot of videos are there regarding the wide variety, like some organic topics are there which are very high scoring that need to be taken care of specially. So now how to reach your topic smartly? First come to the one shot catalyzer series, or you can press any chapter wise also. Okay, so what is this one shot catalyzer crash course? It is almost all chapters are going to be covered. Some are already covered, some are going to be covered in within one lecture only. Okay, but it is one lecture, it does not mean that we will skip some topics. All formulas are included, all tricks are included. So that's why some videos are lengthy, like some are 2 hours, some are 45 minutes, depending on the chapter and the scoring. Okay, so you can select the required chapter. Okay, suppose atomic structure. So here in the atomic structure it is a playlist. Here you have the all one shot series and some more are going to be included here. And before going to any, after completion or before going to anything, just check the description here. Okay, so in the description you will have, see, one atomic structure in one shot. Okay, and that entire chapter list will be here in the description box. Atomic structure complete playlist is given here. Okay, so I hope all of you will follow Whichchem YouTube channel and get benefited. Now we will see how to delete the, how to make the automation process of your WhatsApp. Okay, let's start. Okay, students, now we are going to start with states of matter one shot. So in some books it is given as gaseous state also. Okay, so it is also called as gaseous state. Okay, so gaseous state of class 11th or first year are states of matter. Okay, now we are going to complete it in one shot, and after this we have two types of two levels of questions. Okay, one is a simple pyq level 1, and after that pyq. Okay, actually based upon this level 1 some questions are discussed, that is of the level 2. Okay, so after one shot series I expect all of you will complete both pyq1 and pyq2, so that you can check whatever we are learning in one shot, is it in comparison with the PYQ, means previous year question. So are they in comparison with the whatever the questions they are asked in our previous exams? Okay. So after that I will try to provide you with the DPP. Okay. So if you do all of these steps, definitely there won't be any doubts as per me. Okay. So let's start with the one shot states of matter. Okay. Okay. Now let us see first topic. Just a minute. Okay. See, we will start from the very basic, as if you are nil in the states of matter. Slowly, we will migrate towards the advanced level. So don't get demoralized. It already I know, so why it is like this. Okay. And if my speed is less, you can use the 1.2, 1.5 times speed also. Speed variation also available. Okay. So, but my intention is that everybody, fast student and slow student, both should be able to learn. Okay. So, this is about the gaseous state basically. And in gaseous state, the most variable state. Gaseous state is the most variable state. So, there are some fundamental properties which need to be calculated. Okay. What are those? Volume, pressure, and temperature. These are the three fundamental particle properties of the gases, which always vary and depend one on the other. Okay. So let us take first fundamental property, volume. Okay. So volume of any sample of a gas is considered to be space of the container only. Actually, there is no fixed space. If you keep it in 10 liter, it will take 10 liter volume. If you keep it in 3 liter, it will take the 3 liter volume. Okay. So the volume of the container itself is volume of the gas, and volume is measured in milliliter, meter cube or centimeter cube. Many people have wrong impression that 1 liter is equal to 1 meter cube. No, it is decimeter cube. Okay. So that's why this relation is given. Cc stands for cubic centimeter. C means cubic, C means centimeter. Cubic centimeter. This is about the relation between the volume and definition of volume and relation between various parameters of the volume. Okay. Now let's see the next one. See pressure. Okay, the molecules of gases are in continuous random motion. So during that, what they will do? They will collide with each other. They will collide with each other and walls of the container also. So because of that collision, container give rise some force that is called as a pressure. So the pressure can be defined as force per unit area. How it is defined as force per unit area, okay, in all directions. And it is measured. There are two types of pressure actually, gaseous pressure and atmospheric pressure. Suppose if I am measuring the pressure exerted by a gas on its walls of the container, then it is called as a manometer. If it is atmospheric gases exerting pressure on the earth surface, that is called as a barometer. Okay, barometer is measuring the atmospheric pressure, manometer measures the gaseous pressure. Manometer measures the gaseous pressure. There are two types of pressure. Okay, and here mk's unit, SI units are Newton per meter square, force per unit area, and it can also be measured as mm of Hg, millimeter of mercury, or atm, or tor, or bar. So many pressure units are there. Okay, so more number of units, more will be the confusion. So that's why this have to be written properly and understood and applied. Okay, so 1 atm is equal to 1.013 into 10 to the power of 5 Newton meter square. What is the value? 1 atm is equal to 1.013 into 10 to the power of 5 Newton meter square. And when it can be written as a Pascal, 1 Pascal is equal to 1 Newton meter square. This is the terms in the ATM. But bar, this extra value is not there. Only simple 10 to the power of 5 Newton meter inverse. And mostly in the chemistry, the above terms are used in the physics and some other subject. But in chemistry, we will be using this units only. What are those units? 1 atm is equal to 760 mm of Hg, or 76 centimeter of Hg column. Says centimeter, here it is mm, and 760 tor also. Okay, 1 mm is equal to 1 tor. It is equal to 1.013 bar. These are the units of pressure. Okay, we have studied units of pressure also, units of volume also. Now it's time for the third fundamental fundamental property. Okay. Okay, yes, the third fundamental property of gases is temperature. Which nature? Temperature. Okay. Now let us see. Volume is over, pressure is over. Now we are on to the temperature. Okay, temperature can be discussed as hotness. Okay, hotness of a body, or coldness, whether it is cool or hot. Okay, that, but if it is hot, how much hot it is to be discussed. Okay, so therefore this is temperature is measured to hotness or coldness both. Measurement is based upon expansion of certain metal, and that we use mercury. Okay, with increase in temperature, higher the temperature, higher the expansion it should be. Okay, so one of the scales to measure temperature is Celsius scale. This is more important, only one of it, is not everything. Okay, actually the Celsius scale is depending on, Celsius scale is depending on what? Water. Freezing point of water is taken as a 0 and boiling point of water is taken as 100. These values are divided, cut like this. Each 100 equal parts are divided. That each part is called as a Celsius. Understood? It was observed by the Gay-Lussac that rise in volume of a given mass of gas for each degree rise is nearly equal to 1 by 273 times of volume of gas at 0 degrees Celsius. Okay. If V0 is the volume of gas at 0 degrees Celsius, Vt is the volume. So for every 1 degree, there will be increase in 273 part of that. So like that, when you substitute here, you will get this formula. Okay. Suppose at 0 degrees Celsius, it is 2 ml. So with every rise, there will be 2 ml divided by 273. There will be 2 divided by 273. Likewise, 2 if you take common, this will be the V0. So 1 plus T by 273, you will get it. Understood? So till what temperature we are heated, that you will come to know. Okay. Now let's see the next one. Okay, then additional info. Actually, there are certain very minute thing. Okay, sometimes our life, because of the some comfort zone, we don't study in the childhood, and we will realize after some time. It is for them. Actually, temperature scales are three different scales. How many different scales are there? Three different scales of temperatures are there. Kelvin scale, degree Celsius scale, and Fahrenheit scale. Okay, so this is a shortcut formula to convert degree Celsius to Fahrenheit and Fahrenheit to the degree Celsius, and Kelvin is very simple. Okay, T plus 273. What is the formula? T plus 273. Whatever the temperature is there in degree Celsius, when you add 273, then the temperature you will get, it will be in the Kelvin. So total three scales are there. What are those three scales? Fahrenheit scale, F 32 plus, okay, 32 plus 9 by 5 of temperature in degrees Celsius. Then you will get the Fahrenheit temperature. And here it is 273 when you add, then you will get Kelvin scale. So this is a relation between the all three scales. Is that clear to you? Yes. Now let's. What is SATP? Okay, here it is. ATP means standard ambient temperature and pressure. What does it mean? A stands for everything you know standard. A stands for ambient. Okay. So ambient means room temperature. In that condition, the temperature you will take it as a 25 degrees Celsius. Okay. So that is called as a SATP. Understood? Then definition of ideal gas. Now we are going to start. We are completed the basic terminology which we are going to use in the states of matter. Okay, fundamental we have started, and from -2 I made it up to you 0. Okay, now we are going to start about the gas. So what is ideal gas? Okay, so anybody is said to be ideal who follows all rules. Like God said, wake up early in the morning 5 o'clock. Okay, sleep at the night at 9 o'clock. and have lunch at 7 o'clock and have, sorry, breakfast at 7 o'clock, lunch at 1:30, and dinner at 8 o'clock. So if you follow all these rules, then you will be the ideal person. Okay, but waking up at 10 o'clock, sleeping at 12:30, and then skipping your breakfast, having extra lunch. Okay, these are all non-ideal or real. Reality, it will happen. Understood? So that time real gas, but imaginary only we can think. 5 o'clock wake up daily, what we will do like that. It is only imaginary. Okay. So if you go for the motivation lecture also, one day you will follow. Okay. How many of you have seen first day 70 lakhs? Okay. So how it is first day 70 lakhs? Have how many of you have seen that? So those who have seen that, then definitely they are going to be benefited. And it is not some hours of video. It is just 48 seconds. Okay. So just to motivate you early in the morning. Okay. Sorry, 80 lakhs I think. First day 80 lakhs. Okay. So within 48 seconds you will be motivated. Okay. So if not seen, wait, don't spend even a minute. I want less than a minute of you to motivate you. What is the power of hard work which will give you 80 lakhs on first day itself? Okay. So then there is no intermolecular forces between the gas molecules. Okay. Between the gaseous molecule, there should not be any. That means there is no affection at all. Okay. Let it be another molecule, let it be own molecule. There should not be any type of attraction force should not be there. Okay. A gas molecule don't exert any kind of force on each other. Then size of the gas molecule is negligible as occupied volume. Suppose if I say 2-liter container, actually the space required is somewhere around 20 ml only. So its requirement is 20 ml, but it is asking is 2 liter. Like most of the students do. Suppose in school they are asking 30 rupees. You have to bring tomorrow. But what they will bring, they will ask their parent. In school they asked us to bring 300 rupees. Okay. So like that, required volume is 20 ml only, but it will ask and it will occupy 2 liter. Okay. So that is the second point of the ideal gas. Ideal gas means no attraction, no sympathy. Okay. No if, no but, only simple life. Okay. So that is what ideal gas. Okay. Now let's see the next. So ideal gas, I said they are following the, okay. So they are following the rules. So what are those rules? That is what gaseous laws. That is what gaseous laws. Okay. So then for first one, gaseous law, first law is ideal gas, sorry, Boyle's law. Okay. So as we said, there are how many parameters are there? Basic parameters are three: pressure, volume, temperature, and sometimes number of moles. Okay. So four parameters. So at least how many laws should be there? Four gaseous laws must be there. So that all four gaseous laws, without wasting your costly time, with the multicolored graph and simple explanation in English, we are going to finish it. Okay. So first one is Boyle's law. So out of these four, the Boyle's law takes care of the pressure and volume. What is Boyle's law? It is a relation between pressure and volume. Okay. So some two people are talking, then other people should not disturb them. Okay. What are the other people here? Temperature and number of moles. So once we give the relationship between pressure and volume, at number of moles and temperature must be constant. Okay. Now according to this, see here, volume is very less. Okay. So that time pressure is more. Okay. More pressure, less volume. But when temperature is reduced, that time volume will be increasing. Okay. So this is one graph for graph drawn at temperature T1, and this is another graph drawn at temperature T2. Okay, this is T2 and this is T1. Now the here hint is T2 greater than T1. Okay, so which chem technique? Which chem technique says that first let me complete, then I will tell you the other technique. Okay, so if P1 P by P inverse proportional to volume or P directly proportional to 1 by volume. Okay, so then it will be PV is equal to constant. PV is equal to constant if P1 is the pressure when volume is V1. P2 is the pressure, volume is V2. Then temperature is same. Then P1 V1 is equal to P2 V2. Okay. And all those graphs drawn according to the Boyle's law. According to the Boyle's law, they are called as a isotherm. Iso means same, thermi means thermometer, temperature. Okay. So by keeping the temperature constant, if you draw a line, graph, anything, that graph is called as a isotherm. Okay. So this is the trick. Okay. In PV curve, as we move away from the origin, then temperature increases. Okay. So first let us use this one and then clear off all. And now here it says that as we move away from the origin, temperature will increase. Okay, that is for Boyle's law. Boyle's law graphs are called as isotherms. Okay, so temperature is constant for each and every temperature. But when you change temperature, the parameters also will change. Okay. Okay, here there is some additional information. There is some additional information, additional types of graph. Okay, what are those additional graphs are here? Boyle's law can also be represented using the following graph. Okay, so normally P and V inverse proportional, that is non-linear. Okay, so but now we can get it into the linear. Okay, how we can make it linear? By making it directly proportional. So P directly inverse proportional to V, but we can say P directly proportional to 1 by V. So if I take 1 by V on x-axis, 1 by V on x-axis and P on y-axis, then that line will be passing through the origin. Okay. Now the questions are very complicated on this one. Okay. So slope of this line. Okay. Question will be about the slope of this line. So PV is equal to nRT. PV is equal to what? nRT. So we can write it as a, for this line, additional information. That's why I'm telling you. It is not that simple graph I will tell you and you will learn. That is not the thing. Okay. So here P, for this type of graphs only there is separate lecture. Okay. As it is a one shot, we have to just touch the things. Whatever the topic you have doubts, you can go through the individual topics. Okay. And P is equal to nRT into 1 by V. So then when you compare it with the P, y is equal to mx. Okay, on x-axis 1 by v, on y-axis it is pressure, but slope is equal to nRT. Is it understood? Now how they will make, see here, they will give you the three lines 1 by v and p. They will say that these are the three lines. Okay, this is the temperature T1, temperature T2, temperature T3. Then relation between T1, T2 and T3, greater than, less than, equal. Okay. Here what we should write? Question is what we should write? T1, for this graph I am asking, T1, T2 and T3 greater than, or greater than, less than, like that you have to answer. Okay, fully now. Actually here see, slope and temperature both are directly proportional. Here slope is what? Slope is equal to nRT. So higher the slope, higher will be the temperature. This is having higher slope. So that means higher temperature. So answer will be T1 greater than T2 greater than T3. Same way, if they change the number of moles also, okay. So if they write N1, N2, N3, that time also N1 greater than N2 greater than N3. So this is the relation between this type of graphs they are giving, okay. Now here slope is 0. Why slope is 0? See, PV is equal to nRT. Okay. PV is equal to nRT. Here, T is constant, R is constant, N is constant because here only pressure is changing. So what these three variables are constant. Now this intercept here, they will ask intercept. Okay. Intercept is directly proportional to number of moles of gas, directly proportional to temperature of the gas. Okay. Same case with the volume also, no problem. Okay. So here again it will be PV is equal to what? nRT. Now slope is 0, so intercept is directly proportional to N. Intercept is directly proportional to T. This is type of the information you have to get from the graph. Okay, I think it is now clear. Nobody is having any doubt about this. If you go through like this each and every graph, all questions will be solved. Okay, so we have completed the Boyle's law successfully. We completed Boyle's law successfully. Now Charles' law is about the temperature and volume. Boyle's completed the relation between what? Pressure and volume. Pressure and volume was the Boyle's law, where number of moles and temperature will be changing. Sorry, constant. Okay. Now here the Charles law is relation between volume and temperature. Volume and what? Temperature. And the temperature must be absolute temperature. What is absolute? That means Kelvin scale. The temperature explained in the Kelvin scale is called as a absolute temperature. Okay. Now mathematically, simple, if you heat a gas, then it will expand. Volume directly proportional to temperature. Volume directly proportional to what? Temperature. Okay. So V by T is equal to constant. So that constant V1 by T1 is also constant. V2 by T2 is also constant. Therefore, V1 by T1 is equal to V2 by T2. And whatever the graphs you obtained, they are called as a isobar. Already you must be knowing bar are units of pressure. So here pressure is constant. That's why they are called as a isobar. And with your cute hands, what you will write? You will write like this, a tabular form after the completion of lecture. Boyle's law, okay, Charles law, then Amundsen's law or Gay-Lussac's law, okay. Gay-Lussac's law is mostly used name. So the graph names are called as, okay. So the graph in the Boyle's law are called as iso. The graphs obtained in Boyle's law are called as isotherms. Okay. Graphs drawn in Charles' law are called as isobar. Like this, if you make short notes, nobody can stop you joining an IIT with flying colors. Okay. That too, you will go for the computer science. They will ask you whether you will take what do you call IT. Okay. You will say no, I am here only for the computer science. Okay. Okay, Charles' law, is it understood now? Charles' law and Amundsen's law that we will discuss. So like the short notes, cute notes you have to maintain. And if you already made it, kindly send it to me. I will be very happy to have a students or subscriber like you. Okay. So let's see the next one. Here it is graph V and T. So this is drawn by that graph drawn by the taking P1 at constant pressure, P2 at constant pressure, P2. Okay. So these are the straight line, but I could not draw. I am very sorry from the bottom of my heart, but I will try my level best, sir. So this is the graph drawn by taking at P2. Okay, this is the graph drawn by taking at P1. Is it understood? So here slope again matters. Everything is decided by the slope. Okay. Now how you will come to know PV is equal to nRT, V is equal to nR by P into T. So temperature is changing on x-axis. So nR by P, pressure inversely proportional to slope. Higher the slope, lower the pressure. Here slope is more for this line. So therefore that pressure will be less. Slope is less means higher pressure. Like this you have to calculate. Is that understood? This is about the Charles law. Okay, next law is Gay-Lussac's law. See, main three laws, fundamental properties, what I told you, pressure, volume, and temperature. Okay, what are those? Pressure, volume, and temperature. So this was given by Boyle's law. This was given by Charles' law. Now it will be given by whom? Hamilton's law or Gay-Lussac's law. Okay. So Gay-Lussac's law is a relation between pressure and temperature. So once the pressure and temperature, moles or mass of the gas must be constant and volume also must be constant. So P by T is equal to constant. Okay. So if P1 and P2 are volume of the gases, T1 and T2 are respectively, then volume is constant kept. Then P1 by T1 is equal to P2 by T2. Same thing here. Okay. So graphically explained, here it is called as a isocars. Okay. In the previous slide, I have written two things. So now you have to write the third thing as a isocars. Okay. Graphs obtained in the Gay-Lussac's law. Graphs obtained in Gay-Lussac's law are called as a isocar. Okay. Now again same. Slope is greater for lower volume. See here, V3 is having more slope, but volume will be less. What will be less? Volume will be very less. Okay. So this is about the Gay-Lussac's law. So this is about the Gay-Lussac's law. Okay. Now let's see the next law. So before going to the next law, it is only consolidation time. What time? Consolidation time. So as of now, whatever the laws we have, we can make a good equation. That equation is called as a combined gas equation. What it is called as? Combined gas equation. Combined gas equation is okay, combined gas equation means it will be three laws: pressure, volume, and temperature. Okay, so for any sample of ideal gas, the formula will be PV by T is equal to constant. Okay, now if at one condition the for a given mass of gas P1, T1 and V1 and T1. Then another condition P2, V2 by T2. So both will be constant. Therefore, P1, V1 by T1 is equal to P2, V2 by T2. Okay. So this is what the combined gas equation is. Okay. Now let's see the next one. Okay. Next fourth parameter is introduced. Up to now we have used only three parameter fundamental parameters. Okay. So what is that? Yes, number of moles. The fourth parameter we need to add is number of moles. Okay. So number of moles if we add, that is added by the Avogadro. Okay. Avogadro law is very simple but sophisticated. It states that equal volumes of all gases at same pressure and temperature contains equal number of molecules. Don't misinterpret with atoms. So many times people don't study up to the last. They are writing suppose 20 liter of nitrogen and 20 liter of ozone contains equal number of atoms. No, okay. Actually, equal number of molecules. See, N2 and O3. So number of atoms will be more in 20 liter of ozone. Number of atoms in less in the 20 liter of nitrogen. So I think you will remember this. Okay. Molecules are very, very important word, trapping word. Like 1 mole always contain these many molecule. If two gases contain equal number of molecule, they must also contain equal moles. Sometimes we can say V directly proportional to N at given pressure of temperature, and this is called as a Avogadro's law. Which law? Avogadro's law. Okay. So once we got some new law, now it's time for adding that also. So then we will get STP. Okay. So why we got that 22.4 liter? Just because of the Avogadro's law only. What he has done, he has substituted all formula and calculated the volume. Then he found that 22,400 is the volume, milliliter is the volume occupied by it. And that occupied volume, whatever the mass is there, that is called as a molecular mass. Okay. So once they ask molar density is equal to observed molecular mass equal to density into 22.4 liter. So this is what molar density. Okay. I think it is clear now, everybody. Okay, these are the R values. R values are used in the PV is equal to nRT. Okay, so R value is independent of the quantity. This is a combination of all four laws: pressure, volume law, and Avogadro's law, Charles law. When you combine all of them, what you will get? You will get ideal gas equation. In the ideal gas equation, most of the student facing problem is value of R. So R units will be, you can derive from here by substituting pressure in atm, volume in liter, number of moles, and temperature in Kelvin. You will get the units of the R value. Okay. So R value is independent of quantity but depends upon the units of other parameters. So R is equal to 0.0821 when volume is in liter, pressure is in atmosphere, and this mostly it will be constant. Only these people will be changing. So when it is in joules, okay. Otherwise, we can write it as a pressure is in Newton per meter square, volume is in meter cube. Then this total it can be written as a joules, okay. And you know that 4.184 joules is equal to 1 calorie. So we can simply write it as R is equal to 2 when question is in terms of the energy and calories are given. What are given? Calories are given. Okay. So this is all about the up to the universal gas constant and ideal gas equation. Okay, here different forms of the universal, ideal gas equation. Okay, what are those? When moles are given, then you will use PV is equal to nRT. When mass of the gas is given, you will use PV is equal to mass upon RT upon molecular mass. When density is given, use PMO, molecular mass is equal to DRT. Otherwise, P is equal to DRT by molecular mass. These are the three forms of the ideal gas equation, which is mostly found used in the numericals. I think it is clear to all of you. Okay, students. Now today it is next after the gaseous law. Now let us discuss about the Dalton's law. Okay, all gaseous laws we have studied. Ideal gas law. Now we are going to discuss with the next topic, Dalton's law. Okay, so Dalton's law is regarding the partial pressures. Okay, first of all, Dalton's law statement. Okay, Dalton's law is applicable for the partial pressures, and according to it, total pressure of mixture of number of non-reacting gases. Non-reacting, what is must here? Non-reacting is must. Okay, so then only it is applicable. Non-reacting gases is must. Okay, okay. So then only it is applicable. You can say it as a limitation. There are certain questions for which of the following Dalton's law is not applicable. That you should say whichever reactants, whichever gases are reacting, there it is not applicable. Okay. So according to it, it is the total pressure. Total pressure is equal to sum of the partial pressure. Okay. Actually, what is partial pressure? Here you will it come to know. Partial pressure is defined as pressure of a gas would exert. Pressure of a gas that would exert if alone in the container has the same temperature of the mixture. Okay. Same temperature of the mixture. That means it should be separately. The whatever the pressure exerted at that condition at the same temperature, that pressure is called as a partial pressure. In the same container, first gas is exerting P1. In the same container, the second gas is exerting P2. Likewise, N gases are there, then that is the total pressure. Okay. So P total is equal to total pressure, and assumption it is used and it is confirmed that it all gases are uniformly occupy the volume of vessel. Okay. That means mixture, it should be homogeneous mixture. It is not that in one place it will be more molecule, in another place it will be less molecule. Everywhere uniformity must be maintained. Okay. So that is what the Dalton's law of partial pressure. Now this definition is not important and formula also not important. Okay. But which is important now, whatever I am discussing. Okay. So using the Dalton's law and converting into mole fraction, this formula is important. Okay. So let us, if we want a pressure, pressure of A in the mixture, okay, pressure of A in the mixture is equal to total pressure of the mixture into mole fraction of A. Whichever the gas we are talking about, that mole fraction only we have to take. We have to take only that gas mole fraction. Okay. So now I think it is clear here. Same ways here we want to find out the pressure of the gas 2. Then P2 is equal to X2 into P total. So if I summarize both of them, P total is equal to P1 plus P2. Okay. So in place of the P1, what I can write? X1 into P total. Okay. Plus X2 into P total. Okay. So that this is how we will find out the P1 and P2. Understood? Total pressure. So this is the Dalton's law mathematical form. Another form also there, that is called as a aqueous tension. The next form is of the aqueous tension. Okay. So in general, partial pressure of the gas is equal to its mole fraction into total pressure, or percentage of gas by moles is its partial pressure by total pressure. You will get the mole fraction. Okay. Now application of Dalton's law. Whatever I told you now, that it is used in the aqueous tension. Actually, aqueous tension is the pressure exerted by. Oh, okay, Dalton's law aqueous tension is about the vapor pressure of water. Vapor pressure of water is only called as a aqueous tension. Okay, so aqueous tension is vapor pressure of water. Simply, sometimes it will be given as a H2O, and mainly you should remember vapor pressure of water at the temperature. Okay, so pH2O does not change with the change in volume of the container, change in pressure. It will change only with the temperature only. Okay, pH2O. Then if you want to find out the dry gas vapor pressure, simply moist gas. Sometimes here it will be given as a P moist gas. Okay, pressure of the moist gas minus aqueous tension. Okay, now let's see the next one. Graham's law of diffusion. Okay, we have studied the Dalton's law. Now it is turn for the diffusion. First of all, what is diffusion? Diffusion is simply intermixing of two or more than two gases is called as a diffusion. Okay, and if the diffusion takes place through a small hole, through a small hole, then it is called as a effusion. Effusion is simply escaping of air through a punctured tire is an example. Okay, so that puncture will act as a hole. Understood? The process of effusion always followed by the diffusion. Okay, so that means diffusion and effusion both are same. Only thing effusion should take place through the small hole. Then only it is called as a effusion. Okay, all effusion is a diffusion, but all diffusion may not be effusion. Okay, so then according to Graham's law, what is the formula? Graham's law is applicable for diffusion. Okay, so the diffusion definition we have studied. Now we are going to study about the Graham's law. Okay, so Graham's law says that rate of diffusion inversely proportional to its density. Less density means more will be the diffusion. Okay. Okay, so this is rate of diffusion is inverse proportional to density. Okay, so density increases, rate of diffusion decreases. That is why lighter gases diffuse faster and than the denser gases. Heavy gas will move slowly and lighter gas will move fast. Okay, so this is about the diffusion. Okay, so effusion example is what? The mixing of escaping of air through the punctured tire. Puncture means that hole will act as a effusing mixture. Okay, okay. So this is what the Graham's law formula. This is also not much important, but the next slide is very important. Okay, what is the next slide? See here. If the temperature T1 T2, if the temperature T1 T2. Okay, here these formulas are very important, so try to give importance to this topic. Okay, if T1 and T2 are two temperatures at temperature T1, sorry, two times. Okay, so time required for X gas, X1 gas is T1, second gas is T2. Then at the same volume, here volume is same, then you will use this formula. Sometimes they will give the time same. Okay, so molar volume, let us take same gas is diffusing from the time T1 and from the time T2. Okay, from Graham's law, rate of diffusion, this much volume of gas diffused in time T1, this much volume of gas diffused in time T2. So rate of diffusion is equal to volume of the gas diffused upon time taken. Okay. So Vm by T1 and Vm by T2. That means we can cancel out the orifice means hole. Okay. Orifice is simply hole is also called as a orifice. Okay. Orifice also sometimes they may use the aperture. Aperture also hole only. Okay. And hole also same, orifice also same. Okay, aperture, all the three terms are same. So R1 by R2 is equal to Vm by T1, Vm by T2. And just now we have studied rate of diffusion is inversely proportional to density. See, you can see here D2 is in the denominator, sorry, R2 is in the denominator, D2 is in the numerator. R1 is in the numerator and D1 is in the denominator. Okay. And already you must be knowing 2 into vapor density. 2 into vapor density is equal to molecular mass. So in place of the density, we can write D2, we can write 2 into M2. And in place of the D1, we can write 2 into M1. 2 and 2 will get cancelled, then M2 by M1 will get cancelled. Okay. Now this is a direct formula when you will use in the question if they use the word of same volume. If they use word of same volume, that time you will use T2 by T1 is equal to square root of D2 by D1 is equal to square root of M2 by M1. Okay. Then density of the gases at a given temperature and pressure are proportional to their molecular weights. Okay, that means this is the formula they are using. Okay, so this is about the relation, not that density. Here density is equal to 2 into vapor density. is equal to molecular mass. That formula we have to use it here. Okay. Now let us see the next one. Okay, next it is found that rate of diffusion is inversely proportional to rate of diffusion is inversely proportional to rate of diffusion is also proportional to pressure of the gas. Now we have studied first way, we have studied only density. If we relate the pressure also, if we relate the pressure also, are directly proportional to pressure, inversely proportional to density. Okay. So then the new formula will be like this. Initially we had only relation d2 by t1 or m2 by m1, and if pressure is also given, then P1 by P2, directly proportional. Okay. So this is the second relation. Now let us see the third relation. Okay. Then if the third relation, depending on analysis of the problem, you can use any of the following. Okay. You can use any of the following. So a rate of diffusion can be defined in the following ways. If the question is volume is given, time taken given, you can take this one. And sometimes what they are giving from a tube from left to right. There is a very famous question in a container. From one side it is HCl. In PYQ also I have discussed previous question. From one side it is HCl. Okay. From another side it is NH3. So white ring will form nearby what? Either HCl or NH3. That question we have discussed in the PYQ. So there you will use the distance, and otherwise you can use the volume, or sometimes you can use moles upon time taken, or you can use change in pressure by time taken. These many are the definitions of rate of diffusion. Once again I am repeating. Rate of diffusion is volume of the gas diffused upon time taken. Okay. Volume of the gas upon time taken, or distance traveled by a gas by time taken, moles of the gas diffused by time taken, and drop in pressure of the gas by the time taken. Okay. These are all the four ways of expressing the rate of diffusion. Okay. Now let's see the next one. Then applications of Graham's law. Okay. So first use is to find out our separation of isotopes. So isotopes, what are isotopes? Anything which have same atomic number but different mass number. So according to this Graham's law, if mass is different, then one will move fast and another will move slowly. So it is easy to separate the mixture. Okay, it is easy to separate the mixture. Then it provides the method of determination of molecular mass also. Okay, what they will do, unknown gas X is diffusing two times of oxygen. So with that you will find out the molecular mass of X. This is the method to find out the molar mass. Okay, so this is all about the Graham's law. Okay, Graham's law is applicable for what are effusion. It is applicable for effusion. It is also applicable for diffusion. Okay. Now our next topic is to find out the are some postulates of the kinetic theory of gases. Okay. So kinetic theory of gases is regarding the macroscopic properties of the gases and relationship. Macro means entirely. Pressure is not because of one molecule. Temperature is not because of one molecule. Now we are going to discuss for a given amount of gas, volume directly proportional to absolute temperature. But gas laws does not provide any reason. All gas law says that it is directly proportional, but how it is, what is the experimental proof, what is the mathematical calculation, that we cannot come to know from the gaseous laws. Gaseous laws are only relation, but why it is directly, why it is inversely, that is explained with the help of the mathematical formula and experimental proof or observations by the kinetic theory of gases. That is what called as a kinetic molecular model. Okay. So it is nothing but explanation, experimental observatory explanation of the experimental observation of the gas laws. Okay. Now, according to it is given by what? Maxwell. This kinetic theory or kinetic molecular model is given by Maxwell, and these are some important points. First of all, each gas is made up of large number of identical small tiny particles. That time this molecule word was not known. Okay. So now then he introduced, they are called as a molecule. Okay. Then the volume of the molecule is so small that they may be neglected in comparison to volume occupied by gas. This point was there in one of the previous year question also. That's why doing the previous year question, and first of all in any chapter what you have to do, you have to go for the one shot. Okay, so after one shot you should go for the PYQ, previous year question. Okay, then you should solve the DPP. During this, whatever the problems you have to assess, I am weak in the Dalton's law. Okay, so then go for the Dalton's law lecture, separate lecture are there. So like that, if you complete all these four steps, definitely you are going to get the seat in. If you are a medical student, you are going to get the seat in AIMS, or if you are an IIT student, then you are going to get in the IITs, because all the way you are perfect now. Okay, numerical, theory, practice, question framing, everything you will be aware. But it is time taking. Okay, but you wanted to save some lakhs of rupees and wanted a good career, you have to do this at least 4 to 5 months. Okay, so if you have only 3 months, at least go through the one shot and go through the PYQs. Okay, and if you still get the time, then you can go through the NCRT. But one shot PYQ are compulsory if you have 2 to 3 months. Okay, if you have 4 to 5 months, then you can go for the other steps, DPP and topical lectures. Okay, so it is designed as per your requirement and as per your availability. Okay, so here there are two types of volumes. Suppose we say 2 liter of gas. Okay, actually this 2 liter is not gas, 2 liter is container volume. In that, if you go and cross check, suppose this is a 2 liter container. In that very small volume, if you compress, this is only the volume occupied. This is empty place. Okay. So volume occupied, volume available, volume of the container. See here, I will tell you the relation, because in the real gas equation you will understand easily now. Okay. What is that relation? Now listen carefully. Suppose this is a 2 liter container. What is this? 2 liter container. Okay. Now it is containing, for example, I am telling you 10 molecules are there. Like this, how many molecules are there? 10 molecules are there. Okay, 10 molecules are there, and each molecule of 1 ml. Okay. So now this total container volume is called as a volume occupied. Okay, volume occupied. So 1 ml into 10 molecules are there. So this 10 ml is actually required. Okay, so this is actual volume. Actual volume. Okay, so when you make the difference, what is the difference? Occupied. V occupied minus V actual is called as a V available. V available. So this is the relation between them. Actually in PV is equal to nRT, we should substitute V available. But what we are substituting 2 liter container, so we will directly substitute to 2 liter container. That is what the mistake in the ideal gas equation. So that's why we will make the correction and you will understand why that correction is needed. Okay. So let's see the next slide. Okay, so these are the next points of the postulates. There are practically no attractive forces. This is also wrong point. Okay, previous point also wrong point, this point also wrong point. So ideal gas equations are derived by taking the ideal gas equations are derived by taking the attraction force as a zero. Okay, but practically there is no gas where attraction force is zero. Always there will be some attraction force existing between the molecule. Okay, so because of that they cannot be neglected. Especially they will become more important at the low temperature. Okay, so this was assumption, and that previous also assumption. Okay, then molecule never are stationary. This is correct. Molecule will never rest. Always it will be keep on moving and moving, always in random motion. And this is also there is a step previous year question. They move in straight lines only. Okay, they do not follow the curve path. Always they will move in straight line only. Understood? And the direction will be changing when it collides. So suppose it is moving like this, moving like this. When it collides, then only there will be direction change. Otherwise, it will move in the same direction. Then molecules are perfectly elastic. Okay, and bear no change in energy during collision, but there will be interchange. One molecule momentum may be less, another molecule momentum may increase, but total momentum will be how much? Constant. That is called as a molecular collisions are elastic. Okay. Then effect of gravity on molecular motion is zero. Actually, they are not attracted by the earth because of their small size and mass. Okay. Then temperature is the measure of the kinetic energy. This is very important and numerically important. Theoretically, what is important here? No attraction force and volume point. Volume, the whatever I told you, three times that point is important. And third one is they move in straight line is important. And fourth point is perfectly elastic. Theoretically, these are important. And for numericals, this point is very important. How it is important, that we will derive some formulas. In that formulas you will come to know. Okay, so the temperature of the gas is measure of absolute temperature, that is, see, absolute temperature of the gases. Okay, kinetic energy directly proportional to absolute temperature. What temperature? Absolute temperature. Then the pressure of the gas is due to continuous collision of the molecule with walls. Suppose two gas molecule colliding, that is not a pressure. Gas molecule colliding with the walls of container is pressure. Otherwise, it is not a pressure. Is it clear now? Now let's see the next question. Next slide, sorry. Okay. So speed, I told you there are three types of speeds. There are how many types of speeds? Three types of speeds: RMS speed, MPS, most probable speed, and average speed. Okay, so there are three types of speed. So let us take it as a RMS speed. RMS means R means root mean square. Okay, so here suppose C is the velocity, then we will square it, then mean it, then root it. Okay, we read in this direction, root mean square, but we do in this direction. Okay, first we will square, then we will find out the mean, then we will root it. Understood? So where bar represents that average of c square. Okay, since distribution is continuous, there is no change that every time that value is going to be fixed. Okay, therefore what we will do, we will find out at every temperature 3 RT by m0 molecular mass. Okay, so anyhow you need not to remember this all derivation. So derivation is not required, but at least this formula RMS speed is equal to 3RT upon M. Okay. And so many times, even 2020 advance also this question is asked. Okay. So you can refer, this is the question from the states of matter and graph they are given, studying of the graph for finding out the RMS speed. Okay. Then coming to the second speed, what I told you, average speed. Average speed C average is equal to C1 plus C2 plus C3 dash 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 Cn by N. N is the number of molecule and C1 is the velocity of first molecule, C2 is velocity of second molecule, and so on. Then for continuous distribution, okay, then there it was 3RT by m. Here it will be square root of 8RT by pi m. Okay, this is actually average speed. Since the molecule move randomly, average velocity of the gas is 0. Okay, so actual average speed, and if we take it into direction as a consideration, then it will be 0. Okay, average speed or average velocity. I think all of you are aware that average velocity is a direction quantity and speed is directionless. So if we calculate what by using this formula, so we are getting the average speed, not average velocity. In the velocity, when you consider the direction, the total value will be 0. Okay, the total value will be 0. Is it understood? Okay, now next let us see the next one. Most probable speed. Okay, so there is a small fraction of molecule which occupy either very small or very high speed. The speed occupied by majority of the molecules, whatever, suppose out of 100 molecule, 70 molecules are moving with same velocity. So that velocity possessed by the majority of the molecule. We will draw the graph how many molecules are having how much speed. Then this is the number of molecule, this is the speed. So speed corresponding to maximum number of molecules is called as a most probable speed. On the x-axis it will be what? Speed. And on y-axis it will be number of molecule. Okay, so more number of molecule is having this speed, so that speed on the x-axis is called as a most probable speed. Okay, so this graph question only it is given in the advanced examination. Okay, now if you find out all the three velocities for the same gas, highest value you will find it in the RMS, lowest value you will find it in most probable, average will be in between. So the question was about this graph only, okay, this value only. Understood? So you can use this as a conversion factor. Very, very important formula. C average, CRMS values lie in the vicinities of MPS. Okay. So numerical value of most probable, average and RMS speed increases with increase in temperature. Let it be any type of speed. RMS speed, most probable speed or average speed. Everybody will increase with increase in temperature, increase in temperature. Okay, I think it is clear now. Okay, so here these are the formula, and in chemistry at least you should remember this. Okay, so it is important to note that average translational kinetic energy of a molecule given by, okay, half mv square, half mv square, not average square. Okay, so where n is the number of molecule and k is total kinetic energy. Like that, this is ke1, ke2. If you keep on identifying, finally you will get a formula. That formula, at least if you remember, more than and more than sufficient. Okay, so this is the formula where you have to remember. Okay, from that derivation, 1 by 3 mn upon v c square. C is RMS square. Okay. Is it clear? Note down this formula. Otherwise, P is equal to, pressure is equal to 1 by 3 density into C square, where density is equal to mass into number of moles upon volume. Okay. So this is first most important formula. Okay. Now N by N0 is called as a Boltzmann constant. N by N0 is called as Boltzmann constant. Now let's see the next one. Okay, see here this one. Finally formula what you will remember. This is all derivation. If you can remember it is very well. But kinetic energy per mole is equal to 3 by 2 PV already I told you, and 3 by 2 RT also. Okay, and R by N0 is called as a Boltzmann constant. R by N0 is called as what? Boltzmann constant. This is per molecule. This is average translation energy of a molecule. Average translation kinetic energy of a molecule, and this is per mole. Okay, don't forget to about this per molecule if the question is this one, and per mole this is the formula. Okay, now next we are going to find out about the real gas. What we are going to find out? We are going to find out about the real gas. Okay. So simply Boltzmann constant, already I told you, divide them, then you will get actually that Boltzmann constant will depend upon the units. Okay, Kb is equal to R by N0. R by N0, Boltzmann constant. Okay. Next, this is the real gas equation. What is this? Next topic is real gas equation. So real gas equation is also called as van der Waal equation. Real gas equation also called as van der Waal equation. Okay. And what is the formula? P plus A into N square by V square, V minus NB. Okay. Where A is corresponds to, that also I will tell you, characteristics of gas and independent of the temperature, but depend on the nature of the gas only. Okay. So now this equation we will be further using, then you will come to know. Okay. So for 1 mole what you have to do, and for n moles what you have to do. So units of A, each and everything we will discuss in detail wherever it is required. A units is liter square atm upon mole square, and very important, A directly proportional to force of attraction between the gas molecule. A value is high if molecules are more attractive. Okay. And B is directly proportional to volume occupied. And this is very important formula, 4 times of the volume of the gas. Okay. Then van der Waal gas constant, A is always greater than B. A is always greater than B. Okay. If A is very high, then gas can be liquefied easily. Okay. Okay, next. Equation 1, whatever I told you, in that if the gas is of 1 mole, then N value is taken 1, N value is taken 1. Okay. So this is what they are substituted, and we get for 1 mole divided by N, we got this for 1 mole equation. Okay. Okay, next, pressure correction and volume correction. The question is that how we got this equation? By doing the two corrections in the ideal gas equation. It is nothing new, it is old equation only. But in old equation what we have done? We have made two correction. One is called as a pressure correction, another is called as a volume correction. Okay. So volume correction says that A upon Vm square is the pressure correction, and V minus NB is the volume correction. Always remember, pressure will be added. There is a previous year question and most of the student answered wrong also. Pressure will be plus, volume will be minus. So P plus P dash, V minus V dash. That is the difference between the volume correction and pressure correction. Okay. Now how it is calculated and why it is, this is the graph. Okay. So for any real gases other than the hydrogen and helium, this is the graph for other than the hydrogen and helium. We are divided into three parts. Up to here it is in decreasing, then it is increasing, and after that it is more than the one value. So for the gases whose Z is always 1 is ideal gas. But there is no ideal gas. All gases Z value will be first decreasing, then start increasing. After certain time that will be more than 1. Okay. So let us plot the variation of Z as a function of P. Then this is the graph we got it. We divided it into how many regions? three regions. First region, second region, and third region. One region we will come to know now. Okay. Okay, region 1, low pressure. Question will be given accordingly. You have to use the formula. Okay, when question is given that low pressure, that means Vm is greater than B. So this is the formula you will use. Don't use on your own. When question is given low pressure, P plus A into V square into V NB you can neglect. What you can neglect, NB value you can neglect. Understood? So then this is the formula and Z value will be approximately 1. At low pressure, Z value will be approximately 1. And what is the exact formula? Z is equal to A minus 1 minus A by RT upon Vm. This is the first region. Now let us see the next region. Okay. Next region is high pressure. Okay, sorry, it is number 2. It is written as a 1. Here it is number 2. Okay, so the region is represented by the portion of graph where it start increasing. So then what we will neglect? We will neglect the A into n square by V square. First we have neglected the NB. Now in the second region we will neglect the A into A upon V square. There you will substitute P. So they went the second region. Okay. Now you can see here Z is equal to 1 plus PB by RT. So Z increases with increase in pressure. Pressure is increasing, then Z also increases. And intermediate pressure. Okay. So again I am drawing it here. So this was in previous page and this is the intermediate stage and this is for this one high pressure. Okay, high pressure is this one and intermediate pressure means this one. So here analysis is very difficult. Sometimes this may be not equal, sometimes this may be not equal. At least we can say that here what is the formula and here what is the formula. Okay. Okay, now let us see the next one. Observation from the graph. Below the at low pressure Z is less than 1. At high pressure Z is greater than 1. At intermediate stages Z is equal to 1. Okay. And why it is happening? Because when low pressure, okay, then it is more, gas is more compressible, attractive forces dominate the repulsion forces. When Z is greater than 1, repulsive forces dominate the attraction forces and gas is less compressible. When Z is equal to 1, then only attraction forces are exactly equal to repulsion forces. Okay. Okay, these are the two observations from the graph. In the low pressure region, most of the intermediate pressure, that is Z less than 1. Okay, so that means less than 1 means more compressible. Attractive force dominate, Z greater than means less compressible, then repulsion forces dominate. Okay, now let's see the next slide. Okay, next slide is about the graph shows the variation of Z versus P at different gases. As of now, we have changed the pressure. Now we are going to change the graph. Oh, sorry, change the gases. Okay. So here, what the observations you have to make: helium and hydrogen. These are the two gases which is always positive side only. Okay. So they show the positive deviation. Real gases with the positive deviation. What are those two gases? Hydrogen and helium. But in case of the nitrogen, methane, CO2 and all gases, they are at least showing some deviation which is less than the ideal gas. So these gases are negative deviation gases. Okay. So this is what actually supposed to be. Understood? So that is what written here. Hydrogen and helium gases have very low attractive forces between the gases molecule. Therefore, van der Waals constant between them is 0. Once they say hydrogen and helium, for them positive deviation gases, this is the formula. Okay. So for hydrogen and helium at even at low pressure, we can assume that P is equal to 0. So sorry, A plus A V upon M square is equal to 0. Okay. So for other gases, what we have to take, that we will see here. Okay. Now let's see the next one. So Z greater than less than 1 for what gases? CH4, CO2 attributed to predomination of attraction forces. In them, attraction forces is more. For hydrogen and helium, repulsion forces are more. Okay. So at the temperature of experiment where Z can greater than 1 due to dominance of strong repulsive forces among. So wherever you find that Z greater than 1, that means repulsion forces are more. Z less than 1, that means attraction forces are more. Okay. So all gases sufficiently at high pressure will always be Z greater than 1. We have seen they are going to be less than 1 only for certain duration. After that, they are also getting more than 1. So that's why they are greater than 1. Okay. So that means after some pressure, repulsion force will automatically become dominating. Okay. Now let us see the variation of Z versus temperature. So all the variations we are doing, Z value with respect to pressure, Z value with respect to gases. Now it is Z value with respect to temperature. So this is the temperature, this much deviation is there. And another temperature, when we further reduce the temperature, increase the temperature, here it is given T3 greater than, T2 greater than. So deviation have reduced, here deviation have reduced. So that keep on deviation is reduced at certain temperature. They both will become same. So that temperature is called as a Boyle's temperature. Okay. In the low pressure region, Z is less than 1. Okay. When T increases, Z increases and reaches close to 1. See, when temperature is increased, this is the low pressure region, negative deviation. But when temperature is increased from T1 to T3, then it is reaching close to 1. At high pressure region, Z is greater than 1. Okay. So that time what we have to do, as temperature increases, Z increases and reaches close to 0. Okay. So and it is seen that Z approaches 1 as T increases, Z approaches 1 as P approaches 0. Okay. See here, pressure is decreased, then it is 0. That means Z is equal to 1. When temperature is increased, that is, so to reach Z is equal to 1, high temperature, low pressure are, that means a gas behaves as an ideal gas at low pressure and high temperature. Okay, this is what we observed from this graph. Okay, other, that is low pressure, high temperature ideal gas, high pressure and low temperature will be real gas, because there it is showing the Z either greater than 1 or less than 1. Okay. So let's see the next graph. So large value of Z denotes larger the dip. Larger value of the A denotes larger the dip in Z. Okay. So for example, so many times this question came. Ammonia A value is greater than nitrogen because intermolecular forces are hydrogen bonding. Nitrogen is only van der Waal. Same way, but nitrogen B value is greater than NH3 because size. Nitrogen molecular size is much higher than the ammonia. What you wanted to know, B depends on the size or intersection of A. Okay. Simple molecular size. Then A depends on the attraction force. Okay. So A is signifies the attraction force, whereas B signifies the size. Okay. Now, critical phenomena are liquefaction of gases. So there are certain methods to adopt to convert a gas into the liquid. Okay. When you wanted to convert gas into the liquid, you can do two things. Either temperature can be decreased or pressure can be increased. So if you wanted to convert into the by using pressure, that liquefaction is carried out. Okay. The phenomena of a converting gas into liquid is called liquefaction. Okay. So liquefaction controlled by pressure and temperature. So Increasing pressure also liquefies, decreasing temperature also liquefies, but there is certain limitation for the pressure. That limitation is called as a critical temperature. Okay, so the temperature above which gas cannot be liquefied, the temperature up to which gas can be liquefied by increasing the pressure is called as a critical temperature. The temperature at which, maximum temperature above which we can never liquefy them. Okay, so that is critical temperature. Okay, so condition for a real gas to liquefy. For making the real gas to liquefy, either we have to decrease the temperature or increase the pressure. Okay, so ideal gas can never be liquefied. This is applicable only for the real gas can be liquefied. Ideal gas can never be liquefied because there is no attraction force at all. So once no attraction, no coming together, no liquefaction. Okay. So that is what the this very important point. Okay. Now let us see the next slide. So critical temperature is temperature for a given gas below which continuous increase in pressure will bring a liquefaction of gas, above which no liquefaction is noticed. What is that is what I told you. And so many times CO2 value they are asking, you can remember 31.2. Okay. So at this temperature, whatever the pressure we have to apply so that we can liquefy is called as a critical pressure. And whatever the volume 1 mole of gas occupying at critical pressure and critical volume is called as a critical volume. Okay, volume occupied by 1 mole of gas at critical pressure and temperature is called critical volume. Okay, these three are collectively called as what? Yes, critical variables. Okay, now let's see this is PC, VC and TC are characteristics of each gases. Okay, now what are the formulas for them? See, TC is equal to 8A upon 27 RB, PC is equal to A upon 27 B square, VC is equal to 3B. Okay, so during the numerical, when you wanted to find out the volume, the best formula is this one because no janjat of A here. Okay, then once you find out B value, you can put it here, then you can find out you can put it here and you can find out A value. So first method is to find out volume by using volume B. Okay. So the gas having its temperature much lower than critical temperature, the pressure is sufficient to liquefy. If present temperature is below critical temperature, just apply the critical pressure. Okay. The numerical value of this is very, very important. Okay, so PV, this is what called as a Z. Okay, because Z is equal to PV upon RT. Question so many times it is asked, compressibility factor of any gas at critical variable, critical condition will be 3 by 8. Okay, so this is what 3 by 8. Understood? This value you will remember. Okay. So just it is got by the dividing all the values and substituting in the PV by RT only. Okay. So PV by RT is equal to 3 by 8. I think it is clear now. 3 by 8 is the value you will remember at critical temperature, pressure and volume. Okay. Now let's see the next part. Okay, boils temperature. Just now I told you once you increase, keep on increasing the temperature, the depth will be, deviation will keep on decreases. So this is the temperature at which no deviation. So that temperature at which no deviation is found. The temperature is called as a Boyle's temperature and formula is A by RB. Boyle's temperature of any gas is always higher than the critical temperature. TB is greater than TC. Okay. So the temperature at which real gas behaves as a ideal gas for over a pressure range is called as a Boyle's temperature. Okay. Next, collision frequency and mean free path. So collision frequency means simple number of collision taking place in unit time in unit volume. In unit time and in unit volume is called collision frequency. It is advanced question based on this. So previous advanced question. Okay, so diffusion coefficient, there this value was used. You can refer advanced question also, you will find this. So z is equal to pi into n square sigma square by c average upon root 2. Now what is lambda? Okay, so average distance between distance traveled by a molecule between the two collisions is called as a mean free path. Suppose this is the collision taken place between them. Then this molecule moved here and then collision took place. So this distance is called as a lambda. Two successive collision, whatever the distance it is traveled, that is called as a lambda, and sigma is called as a collision diameter. Collision diameter, where n is the number of molecule per unit volume or molar volume, which is equal to see 0.224 meter cube, it is 22.4 liter, or 0.0224 is the meter cube. Then you will get the n value. Okay. Now let's see the next. Collision frequency, mean free path, very important topic for advanced. Okay. So as based in kinetic theory of gases, mean free path is directly proportional to temperature and mean inverse proportional to pressure. So larger the size of molecule, smaller will be the mean free path. Greater the number of molecules, smaller will be the mean free path. Larger the temperature, larger is the mean free path. Larger the pressure, larger will be the mean free path. So many factors we have to consider for mean free path. Okay. So these on this basis only they will ask increasing order and decreasing order. Okay. Now we are into the liquid state. So what is the vapor pressure? Okay. So actually when you keep the some liquid in the open container or in a closed container, this molecule will evaporate. So that is called as a vaporization. And at the same time some molecule will come back, that is called as a liquefaction. So that state at which liquid to vapor, vapor to liquid, both are at the same rate, that is called as a vapor pressure. Okay. So that when they are in equilibrium, whatever the pressure exerted by the gas on its own liquid is called as a vapor pressure. And question is why we feel cooling when petrol or kerosene evaporates from our hand? Because see, when only these particles which have the higher kinetic energy will be leaving behind, sorry, left over from the container, leaving behind less kinetic energy. So less kinetic energy, KTG already we have studied, temperature directly proportional to kinetic energy. So high kinetic energy went off, low kinetic energy left over, so temperature will be decreasing. That's why evaporation causes cooling. Question will be what? Why evaporation causes cooling? Because during evaporation, molecule with higher container will be losing and molecule with lower kinetic energy will be left over. Okay. So this is what I have explained is available here. Now next is the surface tension. What is the next topic? Surface tension. See here I am considering the two molecules. Molecule at the surface is obtaining inward pull only. But molecule in the bulk is obtained attraction from all direction. Okay. So this is having some extra force over that. That is called as a surface tension. To the perpendicular to the surface, the force acting is called as a surface tension. Okay, you can go through this to reduce the surface. What we have to do, surface tension, surface area is to be reduced. So surface area is minimum in the spherical shape. That's why water drop always tries to acquire spherical shape so that it can be having the minimum surface tension, maximum stability. Okay. Now let's see the next, viscosity. Viscosity is the resistance to flow. Okay. Suppose this is the container containing liquid and this is at the volume V, and top layer will be moving with high speed, bottom layer will be moving with low speed, but the difference in the speed of both is only dx. Okay. So that is called as a dv by dx is called as a change in velocity for change in distance. Okay, this distance also dx, this distance also dx. Here the difference is dv, here difference is dv. So dv by dx is called as a velocity gradient. Okay, and it also depends on area. Viscosity depends on two factors, velocity gradient and area of the uh, planes. Okay, so F is directly proportional to A into dV by dx. Okay, now let's see the next part. So when you substitute here both of them, then there is a constant coefficient of viscosity. Okay, so where n is called as a coefficient of viscosity and units are poise or gram centimeter second inverse. Okay, so what is that coefficient of viscosity, units and everything, it should be clear to you. Okay, now next, thanks for watching. All the best from your Chem, and subscribe if you are new to this channel. Don't forget to give good suggestions and share it to your friends so that lot of things can be happened over a period of time because of your encouragement. And whatever the exams you attempt, I want that you should excel in all those exams. See you. Bye bye. Logging off.